In Chapter 17, we talked about electric potential, which is a measure of electric potential energy. Here in Chapter 18, we're going to start talking about electric currents, which is the electric equivalent to kinetic energy. Before we actually talk about electric currents, we have to go back and talk about a specific type of electric potential or voltage. It's a type of capacitor, which we talked about there. What I'm talking about here is the battery. Now, the history of the battery is quite interesting. This man right here, Alessandro Volta, was in a debate with a man named Giovanni Galvani. By the way, this Galvani is the same guy from which we get the term galvanized, like galvanized steel, so on. So talking about big person here. Anyway, there was a debate about an experiment between the two of them, and to prove his point, Alessandro Volta took strips of copper and zinc and layered them with basically paper towels soaked in salt water. It's basically what he used. And he recreated the experiment. Well, what he just created was the world's first battery. Basically, through that, he discovered that electricity could be created if you have dissimilar metals who are connected by a conductive solution called an electrolyte. Now, this picture here kind of depicts what's going on. Not kind of, it does depict what's going on. Here you have a jar full of sulfuric acid. This is our electrolyte. Okay. Now, inside of this electrolyte, you take two metals and put them in the sulfuric acid. For this particular example, in this picture, you have a carbon metal, a rod of carbon, which is put into the sulfuric acid. Well, they're going to react, and a number of electrons that are in the carbon will then be pulled out by the sulfuric acid, thus leaving the carbon positively charged. Now that it has a positive charge, we call that a positive electrode, or more commonly, a positive terminal. Now, zinc, if you take zinc and put that in the sulfuric acid, then you take all of these extra electrons that are in the sulfuric acid, and some of those electrons will be lost to the zinc. And so as a result, zinc becomes negatively charged. And so zinc becomes what we call a negative electrode or a positive terminal. Excuse me, negative terminal. Let's say that right. This is one of the most basic, simple electric cells or batteries. You can do this at home using a lemon with a piece of copper and a piece of zinc, like use a dime and a penny. Or you can do it with a potato. There are a number of ways you can do this at home. Kind of a fun experiment you can try. Now, the basic idea is that batteries are transforming chemical energy into electrical energy. So you have chemical reactions within your cell that are separating charge, creating a potential difference, in other words, a voltage. Remember that term, potential difference just means voltage. So you have a voltage between the two terminals. Now, if you can somehow connect the two terminals, so here's your device, here's your positive terminal, there's your negative terminal. If you can somehow connect them, there's a little light bulb, then electric forces are going to push positive charges along this way and negative charges the other way. And thus you have an electric current, and as a result, your light bulb is going to start to shine, light up. Now you can have a potential difference maintained as long as these chemical reactions in your cell can keep going. And that will keep going until one of the two terminals or both of the terminals become completely dissolved. And once they're dissolved, you no longer have the ability to transfer chemical energy into electrical energy. Now, we showed you a single cell. We can do a multi-cell. In other words, we can connect several single cells together. A very common example of this is a flashlight where you have, say, or a remote control for a TV or something. You have one battery where the inside here you've got your electrolyte inside, usually some acid, we call it battery acid, reacts with one metal to make it positively charged, so your positive terminal, and another metal to make it negatively charged. So you've got that separation of charges, you've got a voltage. If this is a D cell battery, it turns out it would be the same for a AA battery as well. Your voltage would end up being 1.5 volts, 1.5 volts. Now you take those AA batteries and you put them in a flashlight. You put them next to each other so that the positive terminal on one is touching the negative terminal of the other. Well, what this does is this enhances the separation of charges, and as a result, when you have two batteries that have a voltage of 1.5 volts, the total voltage is just the sum of the two. So you would have a total voltage of 3.0 volts.